Okay, so in this question, for n moles of an ideal gas, the following graphs are constructed. Okay, n moles of an ideal gas is given. Following graphs are constructed. Number 1. So this is arrange the volumes, pressures, and temperatures of the following in increasing order. Okay. So let me take this one first. This is question A. I'll take this as B. First, I'll complete question A. So here, pressure and temperature are plotted. So we know very well. In the case of ideal gas, if we plot pressure versus temperature, keeping volume constant, we'll get straight line passing through origin. This is nothing but the Charles law, right? Pressure, Ramagat's law, we can say that. Pressure is Gaseous law. Pressure is directly proportional to temperature at constant volume, right? So we'll get a straight line passing through origin. Now, suppose let the volume be V1. Okay, let the volume be V1. Now, if we take same amount of gas in different volume, say V2, right? Then we get another straight line if we change the temperature of the gas. Okay, so this is at constant volume V2. Observe carefully. If we keep volume constant, we get a straight line. This is at some constant volume V1. This is another constant volume V2, and like that we can plot, okay, P versus T for different constant volume of ideal gases. Now, among V1, V2, which is higher? Which is larger volume, V1 or V2? To find what to do, you take any particular temperature T and draw a straight line. Now listen, in this line, temperature remains constant, okay? As temperature remains constant, then P is, when P is inversely proportional to volume, correct? This is what we call Boyle's law. At constant temperature, if temperature is constant, then pressure and volume are inversely proportional. So as we go above and above, pressure increases, correct? Pressure increases, therefore volume is supposed to decrease. They are inversely proportional. Therefore, here pressure is low and here pressure is high. At high pressure, volume is supposed to be low. So among these two, V2 is lesser than V1. Okay, keeping the same thing in mind. If you do this, listen, so pressure is plotted against temperature, right? You take some constant temperature, right, and draw a line. Listen, at this constant temperature, as pressure increases, volume is supposed to decrease. Therefore, V1 is supposed to be greater than V2. V2 is supposed to be greater than V3. This is for problem B. Okay, then let me move on to problem B. Here, volume is plotted against temperature, keeping pressure constant. Yes, this is nothing but the Charles law. Let me do here. This is nothing but Charles law. According to Charles law, volume is directly proportional to temperature at constant pressure. Okay, so if we plot volume versus temperature, we get straight line passing through origin. Okay, so this is at some constant pressure P. Now, if you keep some other constant pressure and if you plot V versus T for the same amount of gas, ideal gas, we get another straight line. This is at some constant pressure P2. Like that we can plot at different constant pressure, we can plot V volume versus temperature. Okay, listen carefully. Suppose among the P1, P2, which is higher pressure? To find, you choose some temperature T and draw a straight line. Now, in this line, temperature remains constant, correct? As you move on, if you along this line, if you move above, right, what happens? Volume increases. You know very well. At constant, see, along this line, temperature is constant. At constant temperature, okay, volume, right, and pressure, right, volume and pressure, they are inversely proportional. As I said before, Boyle's law. So, as you move above and above, volume increases. Volume increases, means pressure is supposed to decrease. Therefore, P1 supposed to be greater than P2. As you move above and above, pressure volume increases, pressure supposed to decrease. Okay, so keeping that in mind, if you work out for this is because the gas given is an ideal gas. Okay, so ideal gas we can use Boyle's law, right? Therefore, if we took some temperature T and draw a straight line, okay, now along this line temperature remains constant, but if you move above and above, volume increases. Volume and pressure are inversely proportional. Therefore, as volume increases, pressure is supposed to decrease. So P1 is supposed to be greater than P2, P2 is supposed to be greater than P3. Okay, for this problem. Then one more question is given in the same thing. Let me take this as C. Here, pressure is plotted against volume, right? At different constant temperatures. This is nothing but Boyle's law, right? If you plot P versus V, you will get hyperbola, right? And this is plotted at some temperature, some constant temperature T1. This is plotted at some constant temperature T2. This is at some constant temperature T3. Now, let me take some volume V and I will draw a straight line. Then along this line, volume remains constant. And listen, along this line, if you move above and above, what happens? Pressure increases. You know, well, pressure and temperature are directly proportional. Okay, so as pressure increases, temperature should also increase at constant volume. Therefore, if you see, as you move above and above, pressure increases, so temperature must increase. Therefore, if you compare T1 and T2, T2 is greater. If you compare T2 and T3, T3 is greater. Okay, so among the three, T3 is supposed to be the highest. Okay, yeah, this is question number 2. 2 moles of an ideal gas undergoes isothermal expansion from V equal to 5 liter and pressure 5 bar to V 20 liter and pressure we need to find out, final pressure. Calculate the final pressure. Okay, so what are the data given? Listen, 2 moles of an ideal gas. Okay, 2 moles are given. The gas is an ideal gas. Okay, undergoes isothermal expansion. Initial volume is 5 liters. Initial pressure 5 bar. Okay, final volume is 20 liters. And final pressure we need to find out. Let me take the final pressure as P2. P2 we need to find out. And since it is isothermal expansion, temperature remains constant. Here, temperature is constant. Okay, listen, when an ideal gas undergoes expansion or compression, okay, the state is changing, right? Listen, how to compare 2 states of the same amount of ideal gas? How to compare 2 states of same amount of ideal gas? Yes, we have this equation P1 V1 by T1 is equal to P2 V2 by T2. This is at state 1, this is at state 2, or before expansion, after expansion. Okay, since there is no leakage of gas, number of moles remains constant. Okay, and this is an important relation which relates 2 states of same amount of ideal gas. Now, since it is isothermal, temperature is same, so T1, T2 are equal, I can cancel. We need to find out the final pressure. So, final pressure P2 is equal to P1 into V1 by V2. Okay, what is P1 given? P1 is 5 bar, V1 is 5 liters, divided by V2 is 20. So 5 into 5, 25, 25 by 20, right? Or I can write 12.5 by 10 or 1.25. Okay, take a look. Next question. 4 moles of an ideal gas A is mixed with the 6 moles of another ideal gas B. Find the partial pressure of gas A. Find the partial pressure of gas A if the total pressure of the gas mixture is 25. This is actually a very simple problem. Result, 2 gases are given, A and B, and both are ideal gas. This is ideal gas. This is also ideal. Both are ideal gas. So, if I mix these two, I will get A plus B mixture. Mixture is supposed to be ideal. The mixture also ideal. Okay. Now we need to find out partial pressure of gas A. Partial pressure of gas A we need to find out. And total pressure of the mixture is given. Total pressure of the mixture is 20 bar. Okay. And how many moles of A is taken? A, number of moles of A is 4 moles and number of moles of B is 6 moles. We need to find out partial pressure. We know very well, according to Dalton's law, which is applicable for ideal gas mixtures, according to Dalton's law, partial pressure of any gas in a mixture. Okay, now in this case we need to find out partial pressure of A. Partial pressure of any gas in the mixture is equal to mole fraction of the component in the mixture into the total pressure of the mixture. Okay, so what is mole fraction of A in the mixture? It's nothing but number of moles of A divided by total number of moles. I have only 2 species here, so total is nothing but Na plus Nb. Okay, now what is the number of moles of A given? Number of moles of A is 4 moles and total is 4 plus 6 into the pressure of the mixture is 20 bar. 4 plus 6 is 10, so 4 by 10 into 20, so this is nothing but 8 bar. This is the partial pressure of A in the mixture. Remember, partial pressure is nothing but partial pressure of A means pressure exerted by gas A in the mixture. Okay, that we can find out using Dalton's law, but this is applicable only for ideal gas and ideal gas mixtures. Okay, for real gas we need some more corrections here. Okay.